Okay, good evening and welcome. This is Mr. Steele. I'm trying my first video for the 2011-2012 school year. I'm going to start with a problem that I went through really quickly during class and was probably more entertaining with than I actually was informative. So I'm going to start with a word problem this time from Algebra 2. It's a motion problem. It's going to be solved with the system, but in fact we want to get an idea for the picture. So first the problem itself, written right here. Denzel Washington leaves the station in a train traveling at 45 miles per hour. 1 hour later, Chris Pine leaves on parallel tracks in a train of his own, traveling at 60 miles per hour. How long will it take the Pine to overtake the Denzel? So first, of course, we want to get an idea for what this actually looks like. So I'm going to pretend you don't see that. We are going to make a quick little presentation here. Oh, the screen's a little too small. Let me see if I can do this a little bit better. Okay, so there's Denzel and there's Pine. Got them both ready. Let's look at their respective trains. So, going to our preview, what's going to happen is Denzel's going to take off. His train's moving. And then right about now, 1 hour later, Chris Pine's train starts to move. And notice it's moving faster. And we want to find how much time it takes for them to end up at the exact same spot. So how long did it take for that entire encounter to go? So once again, really quickly, since this does seem to show up, Denzel's train starts to move. It's moving at some rate. I can't remember what it was because I can't see the problem. And then 1 hour later, Christopher Pine, who'd just been sitting there before, starts moving a little faster, and we want to find out how much time it takes for him to catch up so that they're at the exact same point at the same time. Obviously, after that point, he'll overrun him, but for now, we're just trying to find out that time. So there's our first motivation. So how can we solve this problem? Well, here we go. Let's get to work. Just got to find my little pen thingy. There it is. Okay, so the system. We've got a motion problem. So one of our best tools that we can use here is a dirt table. So that comes from the equation d equals r times t, better known as distance equals rate times time. And of course we know a lot about this equation because we use it all the time when we drive in the car. Like miles per hour is our rate, the amount of time we drive would be our time, and we can quickly calculate distances. For example, if I say that I drove for 2 hours at 60 miles per hour, you would very quickly be able to say that I drove 120 miles, just because you have a really intuitive understanding of these pieces. So what we're going to do is we're going to try to create a table that lets us list out all these separate pieces of information. Distance equals rate times time. And again, since it's a table, I'm just going to make some space here. So I'm still not perfect at using this little tablet thingy that I have. So we'll start with that. Not the best table in the world, but that's okay. And now let's start by talking about Denzel. So I'm just going to change it to a different color. Let's go with blue. So, Denzel. It says Denzel Washington leaves the station in a train traveling at 45 miles per hour. So his rate is going to be 45 miles per hour. As far as the other information, well, we don't know how long it's going to take. We do know, though, that if we want to figure out how long it takes for the Pine to overtake the Denzel, like overtaking means that they're going to be at the same point in time for that one instant. So in fact, I can already jump and kind of say that my distances are going to be the same. Like it's the only way we can possibly have them at the exact same point. So we're good there. Let's quickly check out the Pine situation. So what is the rate here? Well, it says Chris Pine leaves on parallel tracks in a train of his own traveling at 60. So once again, they're giving us a rate, so we're good to go there. And next we want to kind of talk about the time. So you can tell it's the one piece of the table that we haven't really touched. So what do we know about their times? Well, it says here that Denzel Washington leaves. So he's just leaving, like he's traveling for however many hours. He starts out the situation. So we'll call his time t. Next, for Chris Pine, it says that he leaves 1 hour later. So now I know it's tempting to put t plus 1, because it seems like, oh, well, he's going an hour later. You feel like you should add some time to it, because the clock would be moving forward. But in fact, because he's going 1 hour later, we have to remember the situation. That means Chris Pine is sitting there for a second, just kind of watching what happens. Like, remember our picture here. So Denzel's leaving. He's already moving. Chris Pine's just sitting there, sipping coffee, thinking about Star Trek 2. And then suddenly Chris Pine goes, oh shoot, I gotta catch up. So he starts to leave, and because he's going faster, he will eventually catch up to Denzel. So we're trying to figure out, okay, how can we model that? How can we talk about him leaving 1 hour later? Well, in fact, if you think about the time, whatever time Denzel goes, Chris Pine travels for 1 hour less. Like he's traveling for less time because he has 1 hour where he's just sitting there. So in fact, we can fill it in as not t, but t minus 1. So if Denzel goes 6 hours, Chris Pine takes 6 minus 1, or 5 hours. If Denzel goes for 22 hours, then Chris Pine will be traveling for 21 because he's got 1 hour less that he's moving. So this table looks pretty complete to me. We've kind of got everything in there. Now we need to turn it into equations because, again, we're trying to solve these with a system. So I'm going to change the color so we can kind of see it. Now let's take a look. So the first equation, distance equals rate times time. So d equals 45t. Nothing really fancy there. Second one, so for Chris Pine, distance equals rate, and then it's time. So times time, it's got to be times t minus 1. So for clarity, I'm going to now put it in parentheses so I remember that that whole thing, t minus 1, is my time. So we're kind of ready to go now. We've got our two equations set up. So now we just need to actually solve them. And now we could use elimination, like we could distribute this out, which I'll do right now. Oops. Ghetto sprinkler. We'd have our second equation then saying 60t minus 6d. Just kidding, still getting used to this. And so we'd have these two equations that we need to solve. Well, elimination isn't really the easiest situation here. Actually, I'm going to use substitution. So when we take a look at this guy, like what I see is that both of them are equal to d. D equals 60t minus 60, and d equals 45t. So why don't we just set them equal to each other? Like we'll just substitute one for the others on the other side of the equation. So d equals 45t, and if that's equal to d, so is 60t minus 60. And so there's our actual equation. We just need to solve this equation for t, since again we're trying to figure out how long will it take. Like how long will it take for them to overtake each other. So from here, it's just a little bit of algebra. So again, changing the pen just for simplicity. Let's see, 45t, well I'm going to subtract 60t from both sides. That's going to make a 0 right there. That's going to leave me with a new equation, negative 15t equals negative 60. And then to solve for t, we can just divide by negative 15. Again, making a 1, and negative 60 divided by negative 15 is going to give me t equals 4. So it seems like our answer should be 4. And in fact, I would accept that answer. I'd say that it takes 4 hours for Chris Pine to catch up. Because in fact, it takes 4 hours from the time Denzel leaves the station, or wherever it is they're leaving, Hollywood, to actually end up at the same place as Chris Pine. Well, that's one interpretation. So one answer could be 4 hours, and that would be from the start, or from Denzel's departure. So I'll go from Denzel's, we'll go departure. Sounds fancy. Sound like an airport. But our other interpretation would be to say that, okay, it takes 4 hours from when Denzel leaves, but how long does it take actually Chris Pine? Well, since Chris Pine's time is t minus 1, it in fact takes 4 minus 1 hours. So our other answer, another acceptable answer, just depends on who's asking, would be to say that it takes 3 hours from the Pines' departure. And in fact, in my opinion, that's a pretty complete solution to this problem. We've identified both possible answers here. We've solved a linear system. I mean, it's kind of a little different than our normal linear systems, like the mixture problems. We've solved our linear system. We've looked at it visually, and then we've used a little bit of algebra tools down here to get our answer, and then we've just kind of interpreted it using what we knew from the problem and what our situation was. So hopefully, since I sped through this problem, like the Pines train, since I sped through this problem, hopefully this video has been informative for you. Thanks. Have a good night.